All right, ladies and gentlemen, boys and girls, children of all ages, welcome to the Hibernate fetch types tutorial video where we're going to be talking about the lazy and eager fetch types in Hibernate. So what you're going to learn in this quick video is going to be the difference between eager fetch and lazy fetch, which fetch type you should actually favor, okay, so which one you should use more often, and some tips and tricks that I use on how to use the actual best approach for said fetch types. So first of all, fetch types, what are they? Well, they are a thing, they are created, they are in existence due to the existence of relationships between objects or tables. Okay, that's why fetch types exist. This relationship, so these relationships are reflected by one of the main types of relationships, which is either one-to-one, one-to-many, or many-to-many. Those are very basic database concepts with respect to relationships. You'll map out this relationship in your Java entity class or XML file, but we're going to be talking and looking at the Java entity classes right now using annotations with Hibernate. And when you actually map out this relationship, believe it or not, the default fetch type is lazy fetch type. Okay? So again, to recap, fetch types exist because of relationships, and default fetch type is lazy. So why do we even have these things? Why do they exist, and why should we be interested in them at all, right? So let's assume that we have a user class and an address class. Okay, where a user can have 0 or more addresses assigned to them in their relationship as a one-to-many relationship. Now let's assume we're using a bidirectional relationship. Okay, that means that you can access the relationship from either parent or the child class. Okay, so the user class will have a collection of addresses defined as an instance variable. Okay, so when we load a user row from the database, what exactly does it do? So if we're using this particular instance where we have the user class that has an instance variable full of the collection of addresses, and we go and try to load the user row using the standard Hibernate stuff, the standard Hibernate code, what would it look like? Well, it would run something similar to this. It would say select star from user. Okay, so notice that this does not have any information regarding a join to the address table. This is because we are lazily loading this particular element. We're doing a lazy fetch. So when you do lazy fetches, it does not invoke a join on anything. It just gets the base object, the base stuff, which is considered, which is the equivalent to select star from user. Okay, now if we were to specify eager fetch, Hibernate would just automatically include all of the joins. Okay, so in this particular scenario, since we only have one relationship between user class and address class, if we were to use an eager fetch type, it would run something like this. It would say select star from user, join address on the address ID, the user ID between them. Okay, because in a one-to-many relationship, you would have the user ID foreign key, or as a foreign key on the address table. So we would join using the user ID foreign key. Okay, so that's essentially what an eager fetch does. So then which fetch type is better? You know, that's the golden question here. So since eager fetching loads all the relationships automatically, it's quite a performance hog. So think about it this way. If we had a user class with not just a join to addresses, but it also had a join to profiles and a join to, I don't know, pictures, and a join to this and that and the other thing. Let's say there's hundreds of relationships. Would you really want to, whenever you refer to a user, would you really want it to go and load every single relationship inside of the user class? Okay, you wouldn't. That just doesn't scale when you have a bigger and bigger application. Now, lazy fetching obviously doesn't load any relationships unless you tell it to, which leads to better performance. So eager fetching, therefore, does make for easier programming, since you don't have to explicitly state which relationships you want to load. So therefore, using eager fetching means less code is required. Whereas lazy loading could lead to more bugs, read exceptions, if the entire system isn't properly tested. Okay, and what I mean by this, you're going to actually see in the example what exactly I mean by this, but you can actually get a lazy load type exception being thrown if you don't properly load your relationship first before you actually refer to it. So having said that, all things considered, you should still prefer lazy loading over eager loading, okay, or eager fetching, I should say, as the lazy loading and lazy fetching is more performant. It's much much better on performance, especially when you're dealing with very, very large systems that just wouldn't scale. Every time you would, put in a relationship or put in an eager fetch with the eager relationship joining, it just would be crazy. Because what happens if, the relationship, let's say the address class has another relationship on top of it, it would probably have to load that one and load the next one and load the next one if you are using eager fetching in all the cases. So you just get a cascading loading effect, which just goes crazy. So that's why you should always prefer lazy loading, even though it's more coding. But that's okay, because now we're going to take a look at exactly how you would go about using and creating this lazy fetching and how you should actually, the best practices that I use when using this lazy loading type stuff. So let me flip over now to my actual Eclipse environment, and we can take a look at exactly how to do this. Alright, so now that we're in our little Eclipse environment, we can take a look at the gist of what's going on here. So as I mentioned before, we have the user class, which is the parent class in this relationship, as well as an address class. Okay, so user and address. And this is a one-to-many relationship. So we look at, since this is a bidirectional one-to-many relationship, I have inside the parent class a pointer to the children, which is a set of addresses. And I have in here a one-to-many relationship. Now I make sure to put in my cascade, and I make sure that I'm also mapping it properly as it is mapped by the user instance variable, which is in the address class. So let's flip over to the address class. And in here, again, it's a one-to-many, so therefore this has a pointer back to the parent class, which is the user class, and we have the many-to-one annotation with cascade, and I've specified the appropriate join column, which is user ID. So this is very, very typical bidirectional one-to-many type relationship stuff. Nothing fancy here going on. The fancy stuff with lazy loading comes into play when we actually go to the home controller, which I've just created a controller really quickly, and I've created this in the Spring and Hibernate environment. And what I've done here is I've created two different mappings for request mappings, one for creation of user and the other for getting a user by a user ID. When we create the user, all it's going to do is it's going to instantiate a user object, and it's going to set the username and password for that particular user object. Then I'm going to create an address object, address 1, and I'm going to populate it with 123 Fake Street in Toronto, Ontario, Canada, with an appropriate zip code. And then what I'm going to do is I'm going to set the parent object on the child, and I'm going to create a collection, a hash set of addresses, which is a set of children, and I'm going to add in to that set the actual address that we created, and I'm going to take that collection and set it into the parent object. Okay, so this is, again, typical bidirectional one-to-many relationship stuff, nothing crazy going on here. We're just setting back and forth, and then I'm saving the user object, the parent object, appropriately with a DAO that I've created. Okay, and then we'll just output that the user was properly created. Now here's where the magic will start to happen. I'm going to invoke a getDomain object by ID inside of my user DAO when I actually ask to get this object. And what will happen here is this is just a generic object that's actually in an abstract class. So I've created an abstract generic DAO. And what this does is it uses a template system to bring in the object in question. It opens up the current session inside of the session factory. Again, this is stuff through Spring and Hibernate, and then I will get the object from the session from the persistent class, which will be the user class is what we're actually going to pass in. So we're going to pass in the user class, and because we're using it by the user DAO, and we're passing in the user ID, and this is what's going to perform our select statement for us, right? And it's going to return the appropriate templated object, which will be the user object. Now, the problem with this situation is that the way that we're doing this is we're using lazy loading. So when I hit this part where I'm actually going to display a message based on the user information as well as the address information. So I'm going to invoke the user.getAddresses, and this is where we're going to have a problem because we're using lazy loading, and we're using it because it is the default fetch type. Since we did not specify a fetch type in our relationships, it's using, like I said, the lazy loading. So you'll see exactly what happens here. So I'm going to go to my, I think I called it example project, and I'm going to say create user. Okay, and I'm going to run this. So now it's created user tpage. So it's actually created it in the database. If I want to, I can flip over to my database. I can say select star from users. I see that tpage is in there. I can say select star from address. I can see that the address is inside of my database. Okay, so it did indeed create that object. Now what I'm going to do is I'm going to say get user, and it's by ID. So I saw here that the user ID was user ID 1. So we'll say get user by user ID being 1, and I'm going to run this, or at least invoke this request. And what we'll see is we get an instantiation. We get a lazy initialization exception. So what it's saying here is it's failed to lazily initialize a collection of role blah blah blah. So what's happening here is it's trying to get the user addresses, but since the session has already been closed down, it cannot perform this action. The reason why the session is closed down is, like I said, I'm using Spring and Hibernate here. Inside of my user DAO class, it's transactional. So what happens is the transaction itself for the session factory is only inside of the scope of I should be in the generic DAO. That's transactional, and the scope of the session is only inside of the scope of this particular method. So once we've called this method and it returns the session, it returns the select statement and the object, it closes the session. So now the session is closed and we are outside of the session, inside of the home controller here. So here we are outside of the session, and we try to make reference to user.getAddresses. So since the session is closed, we try to get the addresses, and this is actually called a proxy object we're going to have here. The user's a proxy, and it tries to invoke the Hibernate code to be able to instantiate that join. It tries to join appropriately, and it can't because the session is closed, so we get this exception. So if you're in this situation using Spring and Hibernate, and you need to figure out how to get around this stupid exception, okay, there's one of two things you can do. The first thing you can do is change the fetch types, okay? And I wouldn't recommend this, but I will show you how to do it. You go to the actual relationship here. So we're in the address class. We go to the user relationship. So this is the menu to one side of the relationship. And we will insert the fetch type. So we'll say fetch equals, and we will put eager. Okay, so we're creating an eager fetch type, and I believe since this is bidirectional, I should go over to the user class and do the same thing. One-to-many fetch type equals eager. Okay, so we have created the eager fetch type for both sides of the relationship. I will then restart my server, and what this is going to do is I have it set to drop all the tables and recreate the tables when you restart the server. So I'm going to have to recreate the user just like we did before by going to that URL. So let me make sure my server starts up at the bottom here. And there we go, started up. So now I'm going to go back and say create user again. Okay, so the user's been created. We can verify that by going back to our database. Yes, indeed, the user is there and the address is there. Great. So now let's say get user 1. And now you see it works. It says user tpage, addresses, and you see our fake address that we put in there, retrieved from database. So we're happy now. We don't get an exception. But like I said, that is the lazy way of coding it by using the eager fetch type. That's the less code, but also very, very bad for performance if you have a system that's going to be bigger than it is right now. I mean, if your system is tiny, then that eager fetching is just fine. But if your system actually is going to be growing, obviously that's not a good thing. So, all right, what's the better way to do this? Let me take away the fetch type. So that's going to set it back to being the fetch type of lazy. Okay, if you don't specify the fetch type, then it's lazy by default. So now we're back to lazy instantiation, lazy loading. How can we fix up our code so that it doesn't give us that exception? Well, what we can do here is we can go into our, what I did is I actually created inside of a user DAO. I created this user DAO object. I extended the generic DAO, passed in the user class as the templated object. And what I'm doing here is there's this one key line of code. This is the magic that happens. So as you'll see, this code is actually very, very similar to what we saw in the generic DAO. Okay, we're getting the current session, and we are loading via the get method on the session. We're loading our persistent class, which is our user class. Okay, I can flip over and prove that this is pretty much the exact same code minus the cast to the templated object. Over here, or rather here, we are casting to the actual user object because here we don't have any templating going on. But we have one key line of code here. Hibernate.initialize user.get addresses. So what this does is it tells Hibernate to forcefully initialize the join. Okay, and we do so because we want this to be accessible outside of the transaction once the transaction is closed and outside of scope of this particular method. If you were only dealing with this join inside of this method, then you actually don't need to use the initialize. You could just say user.getAddresses and that will work fine. But since we're referring to it outside of the scope of this particular method, we need to use this hibernate.initialize code. All right, so since this is a different method, I need to change the way my home controller refers to the getting the actual stuff from the database. So we're going to make reference to the user DAO as opposed to the generic DAO. Okay, so how can I do this? Well, my user DAO, instead of saying get domain by object ID, which was for the generic DAO, I'm going to say get user with joins, which is from the non-generic DAO, which is from my user DAO, and I will get it by user ID. So now it's going to invoke this key line of code here. Okay, this is the key. So let's restart the server, and really, I mean, if you fully understand what I just said, then you don't need to continue watching this video because I'm just going to show you that it works. But obviously, if you are curious to see if it really does do the trick, you'll see in just a moment while I restart my server and show you exactly what's going on. One thing that I didn't show you is that I didn't show the actual Hibernate SQL code that actually gets run. So that's unfortunate, but I assure you the SQL that's being run will now do the appropriate join when we hit that initializing line of code. Okay, I promise you. So now let's go to get user1. And sure enough, now we're using lazy loading, which is much more performant, much better for the long run, much better for bigger systems. And we have gotten around our exception. We now properly have our join populated. And that's really all there is to it. So if you have any other joins at all that you need to make sure are there, you just need to say hibernate.initialize, and then you put in your actual proxy object, which is going to be whatever the join happens to be. So you'll say user.get and then whatever, maybe get profiles or get what have you. So you just initialize each one, it will make sure it joins each one, and then you'll be good to go and laughing. You'll be a master of using the lazy loading, and you'll be able to impress your mom and all your friends with your crazy coding stuff. So hope you enjoyed that little tutorial, and I wish you the very best. Bye for now. Happy learning.